to record. So we will be having this module named as EE3306, Internet of Things. Right. So, um, so basically we will be uh, acquiring the knowledge to design and implement IoT systems based on user specifications and the real world constraints in this course. So basically the aim is to learn about IoT and uh, learn about how to design IoT systems that are useful in the real world. So these objectives are actually I have written them in a very short manner, but this requires a lot of learning about different technologies over a period of time to uh, to be able to implement systems that can be implemented and applied in the real world scenarios. So in this module, we'll be focusing on understanding the IoT network architectures, their components, their functions, the future trends, the challenges, and so on. Right. So if I'm going to like brief you regarding the course outline, I would say that first we will be learning about the IoT network architecture, right? Its components, functions of each component, and so on, right? Apart from that, we'll be also talking about the the design of the IoT networks, right? How we can design an IoT network. So that we call as the physical design of IoT. Physical design of IoT. So in there, we will be talking about how we can implement IoT in the hardware level. The hardware implementation of IoT is known as physical design of IoT. So hardware level implementation. So hardware level implementation involves learning the uh, about the IoT in different layers. So we will be talking about the physical layer, the link layer, network layer, transport layer, application layer, so on. So we have basically the layers related to the OSI model, right? So we will be following that same model, and we'll be trying to understand like what are the protocols that we need to use in IoT networks and the different layers. So like application layer, transport layer, network layer. Likewise, we have different, layers to consider. And under those layers, we will be discussing what are the things like that we need to consider uh, when implementing IoT in these layers. We'll be learning about different protocols, different technologies. Like, for example, in the physical layer, we'll be talking about technologies such as like communication technologies, LoRa, Bluetooth, Wi-Fi, Ethernet, so on, right? And embedded systems. Likewise, we have to learn about the technologies under those that fall under that layer in order to implement this system in the physical layer, for example. So likewise, we will talk about these layers, and we will talk about the protocols that are applied in these layers. Apart from that, so that is basically regarding the physical design of IoT. And when we talk about the next step, it would be the logical design of IoT. So, right, so we have to we have to uh, consider the like theoretical aspects of the IoT network and logical design of IoT. So that means that we need to think how this IoT system will work theoretically in the environment, in the actual environment. So we need to consider like parameters such as like power consumption, security, right? Security, data management, and so on. We need to consider factors that can affect the IoT application. Based on the factors, we will try to like we will try to design our system hardware also based on the requirements under this logical design section. Based on the requirements of our IoT design or our IoT application, we need to design the physical design of the IoT. So physical design and logical design are interrelated. So first you will be making the plan in the logical design, and afterwards we will be implementing in the physical design of IoT. So those are just like brief understanding about the physical design and logical design of IoT. We'll be learning about them in in depth the upcoming lectures. So we'll be taking them slowly and going through them one by one. So I think that would be like regarding the first component or the first stage or the, what do you call, like the first chapter in this lecture module. In this module, in the first chapter will be about IoT fundamentals. What is an IoT network? How it is how it is created, and what are the components, and how we can design a general IoT network. So that is basically regarding IoT, the first chapter. Then we will talk about the second work that we'll be focusing on in this module. We'll be focusing on network virtualization. So network virtualization is a concept that is trending as of now, where we will be like virtualizing the network functions. So network virtualization will be the second chapter that we'll be focusing on. Right, so this will be the second chapter. So we'll be focusing on network virtualization. The network virtualization, we'll be going into deep about this. So we'll be talking about network function virtualization, and software-defined networking. So I hope those concepts will be important to you. So software-defined networking. So these concepts are like very much related to networking. So if you are into that, it would be beneficial for you. So then also we'll be talking about cloud computing. The cloud computing also is essential for the IoT networks, and therefore we will be discussing a little bit about cloud computing also in the second or third chapter, right? So in cloud computing also there are some fundamental concepts that need to be like covered, and we will be discussing those things. So basically we will be not only talking about the concepts of cloud computing, but we want to discuss about how it applies to IoT. So we'll be discussing how cloud computing will apply to IoT, and then we will be talking about uh, industrial IoT, where we will be using IoT in industrial scenarios, uh, which is a little bit different to like, uh, you know, consumer based, like home IoT systems, right? So in industrial IoT systems, we have some differences, and we will be discussing about that in this industrial IoT section. So we'll be learning about the network architecture of the industrial IoT, and we'll be discussing about the potential challenges and the technologies that are like proposed for industrial IoT, and also we'll be discussing about those technologies in detail. So we'll be discussing about challenges like emerging trends. Then we have finally about the trends and challenges in IoT systems. So trends and uh, challenges in IoT systems. So in here, basically, we'll be discussing about mainly the trends like machine learning, embedded systems that uh, revolutionize the IoT systems, right? And right, so we also have other concepts such as like digital twins, uh, those concepts that are very new, but that are proposed to be used with IoT systems. So these trends we will be discussing, and then we also want to discuss about the challenges which we face regularly in IoT. So as of now, as I believe, like one of the main or challenges in IoT is the security and the uh, privacy. So the security privacy of data is one of the main challenges with IoT, right? So as of now, like I have summarized what we are going to be covering in this module, like in sequence, right? If you have any question about any of these terms, and if any of if you have any questions regarding anything related to the what I have mentioned, you can ask, or you can mention in the chat box. So I think that is the basic outline of this module, right? So we will be having enough sufficient time, I think, to cover these contents. So I think we have a like a duration. I mean, we have the credit load of 3 credits for this module. So we have 1 hour of online session and 2 hours of interactive session. Right. Okay. So I will talk about the assignments and exams as well to start with. Right. So uh, continuous assessments. Continuous assessments will comprise continuous assessments or assignments, right? Assessments. Continuous assessments will be comprising 30% of the final grade, and the end exam will comprise of 70% of the final grade. Okay, so one student has asked about the software that we'll be using in this module. So basically, you will be working with, I will explain to you in a later while as well. We'll be working with an embedded, microcontroller. I'm like suggesting you to use the ESP32 microcontroller. So you will be working with the IDE of that microcontroller in order to like program that and make it usable for certain kind of application, right? So you have to work with the ID of the embedded system, right? So I hope I gave an answer to you. I will explain to you in a little while about that as well. So when I talk about the continuous assessments, it will consist of like quizzes and a project, right? So there will be like 5% of marks from quizzes, right? And like 25% from the project, right? And this quiz that I will be giving could be unannounced, right? So the students who come to the lectures will be able to face it. Other students, I don't know, you might not be able to face it, but I'm going to give it unannounced. So only the students who face it at that time will get the marks and get the final grade. I mean, score added to the final grade. Then talking about the 25% project is the most important thing, I think, that you have to do. I will give you instructions about this. And this project is what I will be, considering as your mid exam as well, right? This is your mid exam. So there won't be any other exam. This project would be graded as your mid exam mark, and it will be taken as a mid exam mark. So, this it project will constitute of, it will comprise 25% of the final grade. I mean, yeah, final grade. So 70% will be coming from the end exam to be a written exam, and you will be, you will have to answer questions related to the content that I have covered in the lectures for this end exam. And then when I talk about how you can contact me, right? Ways to contact the lecturer, right? So ways to contact the lecturer. regarding your questions related to the module, um, I'm I'm uh, I'm like I'm creating a workspace in the Google, and I'm sharing the link with you, and you can use that space to ask questions about the module, and in there you have like the members, all the members who are joining the group, right? So in there you can ask questions and get it verified. So I'm sharing that link in the chat. You can access it and you can join this uh, space, and you can discuss your problems there. Apart from that, you can, like talking about that space first, I'll be announcing in that space any kind of updates regarding the module. Apart from that, I also will update the announcements in the LMS. So LMS and in the Google Workspace or the Google Space that I shared, right? That link I shared will be used to give announcements and any notifications regarding the module. So if you if you have any um, if you have any doubts about lectures happening or not, you can check in those first. Then you can also contact me. So you can directly contact me via my email, right? vishakab@srtc.az.lk. So those are the ways that you can contact me, and do not send me personal messages. I do not have the time to cater each individual messages. So right. So basically regarding the contacting the lecture is that. And now I will talk about the project as well, right? The project that I mentioned before. So we'll be working with the ESP32 microcontroller. So that microcontroller is used because it's widely available in the markets, and it's cheap in price. I think about 2,500 something nearly 3,000. So therefore, I believe you are able to buy it. So like I want this project to be done in a group manner. So group as a group activity. So you have multiple members. You can have members. I will like define the maximum amount of members. So you can work with your members, and you will only need to buy one microcontroller per group to test out and work with the microcontroller. So if you can buy individually, it's also good. But if you're financially unable, then you can get together and buy this microcontroller. So I hope to do the work related to implementation of codes in the ESP32 during the interactive sessions that we have at the SRTC premises, right, on Fridays from 2 to 4, right? And I also want to ask, right, I don't know whether this time is okay for you. If you're not okay about this, you can contact me by email, or you can put in the space that I mentioned. And then if you're comfortable in another time, which is also possible for me, then we can schedule it to the other time, right? So I believe that batch representatives, they can discuss about this if you have any problem, that is, because normally I face this issue that students don't like to come on Friday evenings. So because of that, I want your confirmation whether you can attend the lectures. If you are unable, then the batch representatives, if possible, discuss and come to final time slot that you are able, or you can suggest me, then we will finalize a good or a suitable time slot for all of us. So basically that's regarding the group activity and the project. I will give instructions regarding these projects in due time, and you have to complete this before the deadline that I specify, and then you have to submit to the LMS and just follow the instructions in that I will give. Right, so basically that's regarding the project. And yeah, so one student is asking about end exam, open book or closed book. It's going to be closed book as of now, right? It's going to be closed book as of now. So I will start with some content related to this module, right? So we are talking about the IoT or Internet of Things. So let's start with the definition of IoT, right? The definition of IoT, right? So IoT definition. So basically, if I'm to like first draw a picture, IoT is uh, is a term that relates to sensors, like multiple sensors, devices, right? Let's say sensors, uh, and sensor based, like embedded system, right? So in here, not only sensors are available, but also we have the uh, sensors based embedded system. So sensors based embedded system, sensors based embedded system, and it is connected to the access point. Access point, we can take it as either Wi-Fi router, so sensors will be connected to a certain access point. So it could be, as I said, like a router, could be a router that is connecting all this data from these different sensors, right? And the router will forward the data to the internet. So the router, let's say it's a router, uh, and also it is also known as gateway. The word gateway is also used for the component that connects the uh, this network, the local network, to the wide area network. Right? So we have the internet that we can draw as a wide network, which consists of multiple routers, switches that are connected in a very unorganized and a complex manner, right? So we have this web of routers and switches, which uh, which is known as the internet, right? And we connect our LAN, our local network, to this internet through this gateway. Could be a router, it could be router and this server that is used to direct the traffic to the to the or intended destination, right? So normally the router has advanced technologies. The current routers have advanced technologies in them that enable them to find out like the best way to route the data forward. So because of that, the router itself can act as the gateway. The router itself can act as the gateway and connect the local area network to the wide area network. Okay, so the gateway is the component that connects the two different networks using its protocols and enable the communication between two different networks. So in here, the IoT devices that lie in a certain local area and connected to this local area network can be connected to the internet through this edge router. Also, we can call router plus. I mean, if required, we can call this router as the edge server as well, because it sorry, it acts as a processing unit at the edge of the network. So this can also be called as edge server. So where we can do both processing and routing of the data. So we will get into that later as well. So as for now, I will just draw simple. I will try to simplify this, and I will say that this is the router, and it acts as the gateway between the local area network and the wide area network. Right. Sorry. So I have not shared the link with all the students. I will share it again. Hope you got that. After you connect the local area to the internet, now we are able to access the resources in the internet. So, I mean, the devices, whatever the data that is collected by the devices, can now be able to be transported uh, through the through our gateway into the internet and to any like location that has connection to the internet. So because of this, we are able to upload our data into a cloud server, right? A cloud server which is connected to the internet, right? So the cloud server is also connected to the internet through a certain router switch. So with that, we can access. The cloud server can be accessed by our IoT, uh, system, right? So our embedded system can transmit the data to the cloud server. So if the cloud server receives that data, the cloud server is able to store the data in its storage and keep the data there, right? So cloud server is not only used for like storing the data, but it is also used for like managing the data, analyzing the data if required, do predictions using machine learning, and then also give the data in a useful manner to the clients. So that is where we require or we use cloud computing at the cloud server. So we use cloud computing at the server to facilitate multiple services, such as data storage, analysis of the data, before that, data management, then analysis of the data, right? Analysis means like understanding the features of the data in a more organized manner, and then make predictions about the data, such that we can make some useful, um, uh, I mean, uh, and we can estimate, or we can understand the data. uh, we can understand what's going to happen in the process in the future. And then we have user interface design and development, where we will be able to give useful data to the users using a very user-friendly interface and also application. So those are the basic things in general that we can do at the cloud server that will enable us to improve the performance of the IoT network. Apart from that, the main reason that we are using cloud, and connect our network to the internet, is that we are able to access that data from anywhere on Earth, right? So if we have the connection to the internet, we can access the data of the IoT network from anywhere on the Earth. So if, let's assume we have the IoT network here in Colombo, and we want to access that data from somewhere else. Let's say we want to access the data from maybe USA. If somebody wants to access the IoT network from USA, they will just have to connect to the internet, and they will just have to connect to the maybe cloud server, which has all the data regarding the IoT network. So the customers from another remote location can access the IoT network and its data using this connection. Apart from that, the employers, or the workers who are running the company that owns this IoT network can also access company staff, or the managers can access the data using the internet. So they will access the cloud servers and get to know the situation of the IoT network. So the managers, company staff members also can stay anywhere on Earth, and they can access the data. So this is the like basic component, architecture of an IoT network. So we'll be going into detail about the connections, about the connectivity of the IoT networks, the technologies used for communication, and for the embedded system development, and the sensors that we can use for different applications, and so on. So that would be regarding how we will be like discussing about IoT. Then, right. So if you have any questions up to now, you can ask, right? And in the interactive session, we will be discussing about more of these contents. However, if we will try to do a lot of practical embedded system coding, uh, and understanding of the embedded systems in the interactive class. Right. So the goal of IoT, the goal of IoT systems is basically to um, improve the connectivity between devices. Sorry. Goal of IoT is basically to improve the connectivity between devices and create a more connected and efficient uh, world, an efficient world, right? By automating the tasks, right? So the main goal, I think one of the main goals of IoT is automating the tasks, right? So you are automating the tasks at the sensor level and sensor-based embedded system level, and then you are monitoring it from somewhere else. So you, like, for example, if you take maybe the previous scenario where we have the sensors based and embedded systems. So the sensor-based embedded system will collect data regarding its environment, right? It will collect data regarding its environment, and it will collect the measurements, and it will, if possible, it will also act on the data that it receives, right? So it will collect the data and it will act and maybe work, or like it will uh, respond to the collected data, right? It will collect the data, it will make some decisions based on the data, and based on the decisions uh, it will carry on its work. So uh, if for example, if the sensor collects some unusual data regarding the environment, based on that data the system will adjust its work, adjust its process, and it will carry on maybe collecting the data uh, with some adjustments. So basically, uh, the target is to make these sensor-based systems as automated as possible, such that the work that the humans have to uh, do is less, right? So we try to make the machines do the work and the humans do less, right? Humans will be doing other works at that moment. So the monotonous works that the humans have to do every day will be reduced by these actions, right? So the like these uh, if like if we have to do the same work every single day, it's going to be monotonous. So in order to reduce that, we can use IoT systems. We can let the IoT system do that monotonous work. The humans will be mainly monitoring the performance of the IoT system. So right, so the basic goal is to automate the tasks and improve the decision making process. Improve this decision making process based on the actual real-time data, right? So we want to do this on actual world with the real time data. So this is the target, right? And so when we are trying to achieve this target, we need to have some skills. So IoT designers, they have to have some, skills. They need to develop these skills. So basically, they need to improve their, programming knowledge as well, like programming knowledge, which I think every one of us can do. We need to improve our programming knowledge, and then we need to embed those programming or the programs that we code into embedded systems. We need to encode it in these embedded systems. We need to then we need to do hardware implementations of all that uh, embedded systems, right? We need to do hardware implementation. Then we need to do the testing and verify its performance. And then we also have to have an understanding about the internet, how the network is working, and how we can access the internet, and how we can upload our data to a certain server. And then afterwards, we also need to know how the cloud servers work and how we can store the data in the cloud platforms. And apart from that, we also have cloud platforms that are like very popular. We can use those cloud platforms also to store our data. So the cloud platforms, there are popular ones. We can use one of those. Then also we can, if possible, we can also be like web developers or web app developers or mobile app developers that can do, who can, you know, develop apps for our specific IoT application. So these are the kind of skills that we might need to, develop while we are learning this module, and while if we are going to implement IoT networks. These are, I believe, some of the skills that you need, and that will be important and useful. So I mentioned to you about the IoT platforms before. So there are many popular IoT platforms that are in use as of now. Like large companies such as Amazon, um, Google, right? Amazon, Google, Cisco, they are deploying their IoT platforms for anybody to use, right? So we have Amazon Web Services, Google Cloud, Azure, Microsoft, by Microsoft. So these are some of the popular platforms that enable you to uh, carry on an IoT network. So you can connect your sensor-based embedded systems uh, through like wireless net technologies or Ethernet connection to this wired connection to these um, platforms. Right. So these have like inbuilt infrastructure, or they have already, existing infrastructure to enable the IoT networks and its functions. So these are really, user-friendly infrastructures, and they give you like different options, and like give you a good user interface that makes you easy to use that application. So these are some of those popular, Amazon, Google Cloud, Azure, Cisco are popular platforms. So different, if you want, you can learn about them. And also, you have like you have the ability to follow courses that are provided by these platforms. Um, I will share with you like a link that you can go and you know, you can go and refer the courses available for free and for subscriptions as well, which can let you uh, know about the architecture and the infrastructure of that uh, IoT platform, for example, right? And so you can check out the courses offered by these platforms. You can follow those courses as well simultaneously while doing this module to understand how it works, like how the IoT platforms work in their company, right? So they will be like teaching how their platform is working and how, how their protocols are working. So their protocols might not be, used in the same way as in the other platforms. So there are differences I think in the different platforms. So we need to, comply with their standards and their protocols in order to use their system, right? So uh, so each company tries to make their system very unique and come up with their own architecture. That's what I wanted to say basically. With that, I would like to end today's lecture. So I hope you got something out of this lecture. So if you have any questions, you can ask in that web space that I mentioned to you, Google Space, or else you can email me, right? And if you want to meet me, you can also do that by emailing, and you can come and meet me when I give you a time slot. And I hope to see you in the interactive session on Friday from 2 to 4. So thank you for attending today's lecture. I'll continue from the next lecture next week. So thank you so much.